These are the notes for section 4.1, and we are solving linear equations. So we've done this before in regular algebra, and we're going to come back and review it and kind of amp up the complexity now that you're in Algebra 2. So to start out with a little bit of vocabulary, we have an equation, and when I see the word equation, I think of an equal sign. So an equation is a statement in which two expressions are equal. So if you look at the expression below here, we have this equation below here. We have two expressions. We have 3/7 x plus 9, and another expression of just a number of 15, and they are equal. So those are the parts of an equation. A linear equation then is when the variable in the case down below here, the variable is x. So a linear equation is when the variable has a power of 1. And so we typically use variable x in our equations, and it must have a power of 1. So remember, the power location is up here, like x to the second power would be x squared. We have a power of 1 up here, which means we really don't write anything. We don't really kind of think of it as having a power of 1, but that 1 is not something that we have to write. The other thing you might think of is, since we do use the variable x so often, you can see in the examples, sometimes we use n, most of the time we use x. We use n in example 2 there, but these equations will, if we graph them, they'll be linear, and hence the title of this section, solving linear equations. So when we graph, this graph is a line. Okay, and the solution then, let me just kind of change that color. There we go, just to separate the vocabulary. So a solution to a linear equation then is a number that makes the equation true. Okay, so we can just say that makes the equation true. In other words, it satisfies the equation. So if we look again down this first example, it's the value for x, so that when I put x here, multiply it by 3/7 and add 9, I'm going to get 15. Okay, so really solving equations is basically undoing the order of operations. So when we look at this, we know our order of operations is, please excuse my dear Aunt Sally, right? P for parentheses, E for exponents, M and D for multiplication and division, A and S for adding and subtracting. So we're going to reverse that. We're going to work from the bottom up. In other words, we do the addition and subtraction first, and then the multiplication and division. We're undoing all of those. So looking at this equation, then I want to undo the addition first. So I'm going to do that with subtraction. And then I'm going to have 3/7 x equals 6. And then I'm going to undo the fraction 3/7. We can look at the fraction 3/7 a couple of different ways. We can look at it as 3/7 times x, so we can divide by 3/7. Or we can look at this as 3x divided by 7 and undo both the multiplying and dividing by multiplying by the reciprocal. And that's what I'm going to do. I'm going to multiply by 7/3. 7/3. That makes the math a little easier on the right-hand side here. And so we know reciprocals, the product of reciprocals is 1. So we have 1x on the left, which means just x. And then on the right here, we have 42/3, right? Because the 6 is really 6/1. So we have 42/3, which is 14. So if you know that, that's great. If not, maybe you want to try to reduce the 3 and the 6 up here before you do the multiplying. All right, looking at example 2. 2 is a little more involved, right? It's example 1, we had a variable, and it was just one variable in one location. Example 2, we have a single variable, it's n, but it's in several locations. So we have to not just move numbers like we did in example 1, but we've got to move the variable terms as well. So looking at this example, I'm going to move my variables first. And when I look at this, I approach these questions in this fashion. I know I have a variable term here, it's 5n, and here it's 7n. And so I look at that and say, this is the smaller variable term. I'm going to move this. And the reason why I focus on that is because then when I move the smaller, I'm going to subtract my 5n. Then I know I'm going to result with a positive coefficient in front of the variable. So that's how I approach it. So we have an 11 on the left, we have a 2n on the right minus 9, and now we've combined those variables, so now we can work on the numbers. So I'm going to have to move my 9 now. I'm going to have to move this to the other side. So this is a minus 9. I'm going to undo that by adding. And so I have 20 on the left and 2n on the right. I'm going to divide by 2, and then my n equals 10. Okay, so we've gone through 2 pretty straightforward examples. I just want to get back to that whole, how do you know the number that, how do you know you have the correct solution? And just a sidebar here, it's going to come into play later on in the unit. We really should be taking this this answer and plugging it back into the equation just to make sure it works, make sure we get a valid solution. So if we do that on this one, it's 5 times 10 plus 11 on the left, and it's 7 times 10 minus 9 on the right. That's 50 plus 11 on the left, and 70 minus 9 on the right. And that makes 61 on the left and 61 on the right. So we know that 10 is in fact the correct solution. That's just a good check to make sure you did the math over here correctly. This is going to become super important later on in the unit. In fact, we're going to have to do this at the end of the unit. But right now it's kind of optional. Okay, so moving on to, I told you we were going to kind of amp up the complexity here. So moving on to example 3, you can see this is getting much more complex. We've got a lot more preparation to do before we can actually start what I call solving for x. So we've got some distribution to do here and here. We've got some negative signs we got to keep an eye on, and we've got some combining to do once we get done with that. So let's start with the distribution. 4 times this means 4 times 3x and 4 times negative 5. So we have 12x minus 20 on the left. And then we have to do the same type of distribution here. So we're distributing a negative 2, right? So negative 2 times negative x is going to be a positive. In other words, the negative sign out here is really changing this sign and changing this sign. So we are going to have a positive 2x and a negative 16, and then we have a negative 6x. So we've taken care of the distribution. And now we're looking at solving for x, and I see x in 3 of these terms. And so I've got a couple things to sort out here. Because I have these 2 terms on this side, we're going to definitely want to combine those. So 2x minus 6x. So I'm looking at 2x minus 6x is a negative 4x. Notice I took that minus sign before the 6x because that negative goes with the 6. So 2 subtract 6, we're going to go into the negative values. And then I still have a negative 16. So we have 2x minus 20 here. And now if you notice, I've gotten that to the point where it looks like example 2, right? We got variables on both sides, we got numbers on both sides. This is our strategy. Move the variables, move the numbers, finally divide out. So that's exactly what we're going to do. So I'm looking at the variables here. I got 12x minus 4x. This is the smaller term. So I'm going to move this by adding 4x to both sides. That gives me 16x over here. I still have a minus 20. And I've got a minus 16 there. I'm actually going to move that over to just under the minus 16. These go away. The 4x's go away here. And now I can move the numbers. So I have to move the 20 to the right because my variable is now on the left. And so I have 16x, don't forget the variable, equals 4. And I'm going to divide by 16. Be careful here because we are dividing 4 by 16, not the other way around. So dividing 4 by 16 is going to introduce a fraction. We can leave it as 4 over 16, but if we reduce it, we can divide out the greatest common factor, and that's 4. 4 goes into both those numbers. So then we have an answer of 1 over 4. So like I said, getting a little more complex for sure. And then this last one, I love this example. This example 4 is one of my favorite ones because it looks super duper complicated, right? We got all these fractions, and people start to stress out when they start to see fractions, and so I don't want you to stress out. This is kind of a cool thing. I call this clearing fractions. Okay, so what we can do is we can look at the denominators. So we have a denominator that is, so we're going to look at the denominators here. Our denominators are 3 and 4 and 6. So think of a number that 3 and 4 and 6 goes into. Okay, so if you think about that, it's called a multiple. Okay, and the multiple that 3 and 4 and 6 go into is 12. In other words, we can divide 3 out of 12, we can divide 4 out of 12, and we can divide 6 out of 12. So I am going to multiply, because that's the multiple I'm going to use. I'm going to multiply by 12. Okay, so what that means is that I'm multiplying this first term by 12. So instead of 1 over 3, I've got 12 over 3. Well, 12 over 3, I'm going to write that actually. 12 over 3 is just 4. We'll get to that in the next step. And then the next term, I got 1 over 4, but I'm going to multiply it by 12, so I have 12 over 4. And then this next term here, I'm going to multiply by 12. That just gives me 12x. And then this last term here, I got 1/6. Well, I'm going to multiply it by 12, so it's going to be 12 over 6. Okay, and so what we're going to do here now is this, we're actually going to get rid of all these fractions because 12 over 3 is really 4. This is really 4x. And 12 divided by 4 is 3. And this doesn't have a fraction. And then this last fraction is 2. So now we've cleared the fractions by multiplying 12. I didn't use the vocabulary, but I will now. 12 is called the least common multiple. Least common multiple. So, so then, because we did that, notice again, now we have something here that looks a lot like, I'm going to go scroll back up here, it looks a lot like example 2, right? So since we have something that looks a lot like that, we're going to use that strategy again. So I'm looking at this here, and I'm saying, okay, here are my x terms, here's my smaller x term. I'm going to move that. So I have to subtract 4x, and I've got 3 equals 8x minus 2, and then now I've got to commit here, and now I've got to move the 2 over here. So I'm going to add 2 to both sides. That gives me 5 equals 8x, and divide by 8, and we have an x of equal to 5/8, which we can't really reduce. Okay. So now that we're kind of warmed up here, we're going to look at these problems that are a little more realistic. So here we have a real estate broker. His base salary is $18,000, and she earns a 4% commission on total sales. How much must she sell to earn $55,000 total? So if you think about this, we've got to really kind of make an equation. And so we know, what do we have here that make up, I'm going to do a little highlighting. We have a base salary, and then we have total, she earns a commission on her total sales. So we have a sales We have a, how do we want to say that? We have a sales income. You know, she gets money because she's selling stuff. And then she has a total. So her total income, oops, don't know how to spell total apparently. Total, there we go. Her total income is going to be the combination of her base salary and her sales. And so we know that her total income is $55,000. And her base salary is $18,000. And her sales is a percentage on her total sales. So, and we want to know how much she has to sell to get the 55,000. So it's she gets 4%. She gets 4% in everything she sells. So what that means is that if she sells $100, she gets $4. Okay, if she sells $1,000, she gets $40. So she gets, we have to convert that to a decimal, she gets 0.04 of whatever she earns. So this is 0.04x. So there's our variable, right? This is an equation we need a variable to solve for. And we want to know how much she has to sell. So how much must she sell? How much must she sell is our x. Okay, I'm going to move that down a little bit so it's a little farther away from my annotation. Okay, so now we can go ahead and solve this. So I'm going to subtract my 18,000. I just have x in one spot, so I just got to move these numbers, just like that first example, right? That's all we had to do is move the numbers. So that is 0, 0, 0, 15, it's 7, looks like 37,000 equals 0.04x. Then I divide by 0.04. It's a really tiny decimal, hey? So we're going to get a really big number. Think about only getting $4 when you sell $100 worth of stuff. You got to sell a lot to make up $37,000. So she's got to sell, I would do this on a calculator, 37,000 divided by 0.04. She has to sell, wow, $925,000. I'm just looking at an answer key. I didn't do that in my head. Almost $1 million worth of stuff. But it's a real estate, so you know we're talking homes. So it might only be a couple of homes she has to sell each year to reach that amount. All right, this last example, example 6, we have a 3-inch by 5-inch photo. So this is kind of a geometry application. So we have a 3-inch by 5-inch photo. So 3 inches by 5 inches photo, that photo that you want to enlarge. And then you want to mat it and you want to frame it. Okay, that makes sense, mat and frame. Okay, so you want the width of the mat to be 2 inches on all sides. I'm re-evaluating how I sketched this out. A little bit of a restart here. I'm going to put these dimensions on the inside, not the outside, because I have to add stuff to my picture on the outside, right? A mat goes around a picture and a frame goes around a picture, so I have to add stuff to the outside. So there is my picture. This is my photo. Okay, so now, so I've got the 3-inch by 5-inch photo, 3-inch by 5-inch photo, and I want a width of the mat to be 2 inches on all sides. So the width of the mat to be 2 inches on all sides. So that means I need 2 inches up here, and 2 inches down here, and 2 inches down here, and 2 inches at the bottom. So that's 2 inches on all sides. Okay, so that is my mat. And we want the perimeter of the framed photo to be 44 inches. So the perimeter, oops, the perimeter to be 44 inches. Well, so we know that the perimeter is this, right? I'm going to try to draw it as close to the orange as possible. This is the perimeter. So the perimeter is 44 inches. And if you notice with the dimensions I have, if I just keep it at a 3x5 photo, we're not gonna have 44 inches all the way around. So they mentioned that they want to enlarge the photo. So really what they want to do is they want to make the photo bigger, but they want to keep the dimensions multiples of 3 and multiples of 5. So they want to make this not 3x5, but maybe 6x10 or something like that. So really what we have is we are going to have a multiple of 3 and a multiple of 5 to this dimension. Okay, so now we know the perimeter is 2 times the length. Oops, let me change color here. Back to purple. 2 times the length plus 2 times the width. And that's going to equal 44. But this is too many variables. We need just one variable. So let's take a look at the length. The length starts here and goes, starts here and goes to here. Maybe we'll call it the height. Okay, and so if we have the mat here, remember the mat's in orange. If we have 2 inches here and 2 inches down here, that means we've added 2 plus 2 is 4 to this width. So to this dimension. So the length then is 3x plus 4. And then for the width starts here and ends here. And if we again look at this width, we've added 2 on each side with the mat. So we've added a total of 4. 2 plus 2 is 4 to this dimension, whatever it is. So this is going to be 5x plus 4. So we need 2 of these and 2 of these. So it's going to start looking like 2 of the lengths plus 2 of the widths. So if you notice, it's really starting to look like that example 3 equals 44. It's really starting to look like that example 3 where we have some brackets that we have to take care of. So that's the strategy we're going to use. We're going to start by distributing. So I have 6x plus 8, and then distributing with the other set of brackets. 10x plus 8 again. Notice that we're just doubling everything, and that equals 44. And the advantage, we have everything on one side to combine, so that's kind of advantageous. So we've got a 6x term and a 10x term, so we have 16x there, and then we've got an 8 and an 8 to combine, and that's 16 as well. And then we have equals 44. And then now we can go ahead and start to solve this by moving over the number. So we have 16x equals, let's see, 14 minus 6 is 8. And 3 minus 1 is 2. And then divided by 16. So x is equal to, I'm going to reduce this. Hold on here. I'm just going to go to the next page. Oh, I can't really go to the next page. Okay, I'm looking at this fraction here, and I'm thinking 2 goes into both, but that's kind of small. 4 goes into both, so I am going to divide each by 4, and so I am going to get x equals 7 over 8. No, not 7 over 8, 7 over 4. Gotta watch my math there. And so that is the percentage we should enlarge the photo. Boy, that doesn't look like a percentage, does it? I bet if we had a decimal, then we could find the percentage. So if you think about this, this is 1 3/4. So this is 1.75, right? 3/4 is 0.75. Think about the money. In, you know, if you have 3/4, you have 75 cents. So we are gonna, if that's a, that's the enlargement. The percentage then is 175%. So when we go to the copy machine, or however we're going to enlarge this, we're going to specify that we want 175% of the original photo size. All right, so those are the notes for 4.1. If you're following along in the packet, then your 4.1 homework is just on the next page. Notice that you have the answers. Right? The answers are provided here, and that's just to give you some immediate feedback as to whether or not you've done the questions correctly. So so if you get the right answer, go ahead and move on. Have the confidence that you know you've done that correctly. If you're not getting the right answer, review your work and see if you can find your mistake, or come and ask the teacher just to help you find your mistake. And then we'll provide an answer key eventually so that you can really dig into the solutions if you're still